Kia ora, here are the first 3 merit questions in last year's differentiation paper. So I'd like it if you can pause the video and have a go at all 3 of these and just see how far you get through with them, and then of course just skip ahead to what you need. So in the first one we're looking for the x coordinates only of any stationary points on the curve. So what we're going to have to do in this one is to differentiate this function and then find where the gradient or the derivative is equal to 0. So we'll have to solve an equation there. In the next one, we're given a curve, and we have to find the equation of the normal to the curve at the point where the curve crosses the y-axis. So just quickly looking at that one, wherever the curve, whatever curve it is, crosses the y-axis, that means that we're going to be looking for where is x equal to 0. And then to find the equation of the normal to the curve, we're going to find f dash of x at that point, and we're going to use the negative reciprocal, right? Because the normal is perpendicular to the tangent. So that's roughly how that question is going to go. And this last one is kind of a baby-related rates question. We've got a balloon, and we're told that its volume is increasing at this rate, and we have to find how fast the radius is increasing at a particular point. So let's now just get into them and go through them. The first one, we need to differentiate this, so we're going to have to use the product rule and the chain rule. Right, so starting off, we've got y equals 2x plus 3 times e to the x squared. Dy by dx will be 2x plus 3 times 2x e to the x squared. So this is now doing the product rule and then the chain rule on here, plus the other way around, the derivative of this one, which is 2 times this function here, e to the x squared. And that has to be 0 for a stationary point. So looking at this, you can see that we can factorise out 2e to the x squared. So let's take that factor out here. And then we've got 1 for this one, plus x times 2x plus 3 is equal to 0. So e to the x squared is equal to 0, or 1 plus 2x squared plus 3x is equal to 0. So no solutions to this one because it's always positive, but this one here is a nice quadratic. We can look at that, and we should by this point be able to factorise that just by looking. We've got 2x here and x here. We've got a plus plus pattern here, and we've got 1 here and 1 here. Just check that it works. So 2x squared plus x plus another 2x plus 1. And so my two solutions are x is equal to negative a half, or x is equal to negative 1. So let's just go back to the question and check that we don't have to do anything else, right? It's always worth doing that last check. Okay, yeah, we're fine. We just have to find the x coordinates of any stationary points on the curve. So that's a merit question. Let's look at the next one. So we've already talked about how we're going to do it. We're going to differentiate that function, and that's going to use the product rule again and the chain rule. And then we're going to work out what the gradient is when x is equal to 0. And that would be the gradient of my tangent. I need to change that into the gradient of the normal and then use the equation of a line. Okay, so we start off with y is equal to this. And dy by dx will be the first function, u, times the derivative of this, which will be negative 3 sine of 3x, plus the other way around, the derivative of this function, 2x plus 3 times this function, cos of 3x. Okay, now we don't have to set that equal to 0, right? We're not trying to find stationary points, so we don't even really need to clean it up. We have to ask, what are we looking for again? Well, we've got some weird curve, and we need to know what's its value when it crosses the, we're going to need to know the point to find the equation of the line, and we need to find the gradient where x equals 0. So this is f dash of x, right? So what we have to go and do now is to find f dash at 0, which turns out to be really easy, because here this is equal to 2 times this is equal to negative 3 times 0. So that goes. plus here we've got 3, 0 plus 3, times cosine of 0. Cosine of 0 is just equal to 1, so f dash of 0 is equal to 3. That means that the normal gradient will be negative 1/3, right? So that's the tangent gradient that we've found, and that's because perpendicular m's multiply to give me negative 1. So the equation that we're going to find is y minus y1 equals m into x minus x1. That's what I'm going to use here. So that's one way to go. Or if you prefer, you can just use y equals mx plus c. But in either case, we need to have a point. At the moment, we don't have the point. We just have the x value of 0. So the last step is just to figure out what is f of 0, going back to the curve. So f of 0 is equal to 0 plus 0 plus 2 times cosine of 0, which is equal to 2. So my point is 0, 2. And for this one, I've used the point version. The point gradient version. So y minus 2 is equal to negative 1/3 times x minus 0. Y is equal to negative 1/3 x plus 2. So that question's slightly different from things I've seen before. I quite like it. I think it links up lots of different little skills. But once you see what you've got to do, the actual calculus, the differentiation is not bad at all. And then the last one is, as I said, it's a little related rates question. We just have to be careful to read carefully what rates we've been given and what we're trying to find. So the goal here is to find the rate of increase of the radius when the balloon radius is 15 centimetres. This is my formula for a balloon. Remember, in maths, balloons are perfectly spherical. So we're looking for dr by dt. And we can set up a chain rule relationship between r and v in volume as follows. So we're going to find dr by dv times dv by dt. This one we're given, right? We're told that dv by dt is equal to 60. And dr by dv is easy to get if we remember that we can just use dv by dr to start us off. So dv by dr is 4 pi r squared. So dr by dv is 1 over that, 1 over 4 pi r squared. So dr by dt, which is what we're looking for, is going to be this. It's going to be 1 over 4 pi r squared times 60, which is 15 over pi r squared. But we want to figure this out when r is 15, so we can simplify that even further down before we chuck it in our calculator. So 15 over pi times 15 squared, which is just 1 over 15 pi. And when I worked that out, when I was preparing to do this, what did I get? I got negative something. No, not negative something, positive something. So that worked out to be 0.021. Sorry, the pen's going weird. Let's just put it back to the black one, right? 0.021221, and the unit here is centimetres per second, right? Because I'm looking at the radius, which is a length, so it's going to be centimetres, and the unit of time here is seconds. Okay, so that's 3 merit questions done. I'll do the last couple. I think there are 2 in question 3, and then I'll start on the excellence problems later on tonight.